Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem is about vectors, and it's a little bit more complex case about addition of two vectors. Let's say we have this vector and it's horizontal and it's 10, and we have this vector and it goes against the angle, and they always give us the angle, they always give us an orientation, and the length is 15 and let's say this is 45 degrees, and they want us to add those two vectors. And this is a very typical situation in physics. For example, the aircraft is flying this way, but there is wind that blows this direction. So what is the full real speed of the aircraft against the Earth? Or it may be one force pulling this way and another force pulling that way. One force pulling this, another this. This may be 10 newtons, this may be 15 newtons. And you want to know the net force, where it directed, and what is the value of this force, because it would be necessary to solve other things. Or there may be like 5 forces, 5 vectors. We have to add one force to another, to another, to another. We have to learn how to add vectors and be as fluent with this as if we adding numbers. So the rule is you have to take this vector, and this vector you move, so this beginning of this vector comes here, and then the vector moves parallel to each other. So it would be something like this. Let me draw it. 10, and I'm maybe not drawing it to scale, but it doesn't matter. And this is this, and you don't even have to draw arrows in this case. You may, but it's not necessary, because this would be the final, and I wrote 15 in the wrong spot. It's better to write it here. And let me clean it. And this would be the final vector, but we need to find it. And what means to find the vector? If this is, remember I said this 10 and it is horizontal, right? Along this axis. So this axis horizontal, I know the direction and I know the length. This vector is 15 and it's under 45 degrees. Fantastic. And we now need to find this C, and we now need to find this theta. So this theta, this angle, we need to find, and we need to find the length of this vector. And only when we find the length of this vector, and theta, we will say, okay, we know this vector. So the problem consists of two parts. One is finding the length in this triangle, and second, finding the angle. And there are basically two ways of doing this. In this installation, I show you how to solve it through triangles, and later I will show you how to solve it through coordinate system. And both you have to be familiar with. Okay, I wipe it down, I look on this, and I say that there is a geometry. If this is A, and this is B, and this angle is known, right? And angle, it would be C capital. Then this would be C lowercase, and I put this C capital and this C lowercase because the angle, this would be A, this would be B, and this would be C, because A lowercase against A capital, B, angle B, this dot is again B lowercase and C uppercase and C lowercase, and that's the angle. So I can put angle C. so not to be confused. And there is the cosine law. Cosine law. Or we can call it theorem of cosines, but it's called cosine law. And cosine law says that c squared equals a squared plus b squared minus 2bc, right? Or minus 2bc cosine angle c. And in this case we know everything. We say c squared equals 10 squared plus b squared would be 15 squared minus 2 or ba, ab, 2, 10 multiply 15 cosine, and so this angle, the full angle is 180, so it would be 180 minus 45, 180 minus 45 would be cosine 35 degrees. So, you can plug with your calculator those numbers and receive what is c, square root of this. And that's what you will do in this case. So you will know the distance and you know this angle. And after you've done this, you know the length of this vector. I leave it to you to put this. I don't want to spend my time with the calculator or do it in my head. But all I say is that now A is known, B is known, and C is known too. It would be probably longer than 15 just from this picture I can tell. But what exactly you will figure it out. And then the last thing that we should find this angle. And there is sine law. And this sine law, this is a cosine law. For any triangle it's valid. And this is a cosine law. Sine law, I can write it there. For example, that c divided over sine angle c, the side of triangle divided over this sine of the angle that's opposite to it equals b sine angle b. B sine angle b. And finally it's equals the same like a sine over angle a. And in this particular case, c is known, so you can write c over sine, and this is 135 degrees, and you can find out what the sine 35 degrees is. Square root of 2 divided in 2, it's 0.7, but you will find out with your calculator. So this divided over this equals the same like b, and b is 15. So you plug number c, you plug b 15, and you put here sine, and angle b in this case would be theta. And so straight from here you will find sine of theta equals b over c multiplied by sine 135 degrees. So basically, adding two vectors is like drawing them so they constitute a triangle. In this triangle, we know one side, we know another side, and we know angle between those. We apply cosine law and we derive the length of this vector. And to find the angle, we use sine law, because if we know all three sides, and we know this angle, we can find through this sine law, sine theorem, we can find any angle. And so this is this installation of vectors. Would be more, and so to see those and don't miss, subscribe, bell, like, comment, question, problem, and I see you next time.